Here we have a SAT math question. Okay, let's go with the information. The function f of x equals to negative 8 times x negative a times x negative b is defined by the given equation where a and b are distinct constants, where a less than x less than b, the value of f of x is positive. The graph of y equals to f of x in the xy plane contains a point r comma s, where r and s are constants. If s equals to 10, which of the following could be true? So we have three statements and we have to find the one which is true. Actually, the given one, the given function is a quadratic function in intercept form. And also, whenever I sketch the graph of a quadratic function in this form, f of x equal to negative 8 times x negative a times x negative b, I'll be getting a vertical parabola. Okay, now let's consider the intercept form of a quadratic function, that is y equals to a times x negative p times x negative q. So this is the intercept form of a quadratic function and its graph will be a vertical parabola. So if the value of a over here is greater than 0, then the parabola must open up. If the value of a is less than 0, that is negative, the parabola must open down. And also let's consider the value of p, which is subtracted from x in the first factor. This is the x coordinate of the one of the x-intercept of the quadratic function. That is, it can be written as p comma 0. And let's consider the value of q, which is subtracted from x in the second factor. So this q is the x coordinate of the second x-intercept of the quadratic function. That is q comma 0. So whenever we have x negative p times x negative q in a quadratic function, p comma 0 and q comma 0 are the two x-intercepts of the parabola. And if the value of a is positive, that is greater than 0, the parabola must open up. And if the value of a is less than 0, the parabola must open down. Okay, now let's use the stuff we have discussed over here in our quadratic function. So before that, we have an information, y equals to f of x. That is, wherever we find f of x, instead of that, we can consider y. Okay, so here we have f of x. Instead of this f of x, we can consider y over here. And also here the f of x is positive. Instead of that, we can say y is positive. Okay, then we have the given quadratic function, y equals to negative 8 times x negative a times x negative b. Okay, comparing this and this, what do we have for p and what do we have for q? For p we have a, for q we have b. Then what are the two x-intercepts of the given quadratic function? The parabola given by this quadratic function, it will be a comma 0, and the second x-intercept of the this parabola is b comma 0. Now I got the two x-intercepts for the given quadratic functions. And also when I compare the given quadratic function and the quadratic function which I have written over here, so what value do we have at the place of a in the given quadratic function? That is negative 8. So that is a equals to negative 8 over here, which is less than 0. So negative 8. So the parabola given by this quadratic function must open down. So it has to look like this. Okay, now let me draw the x-axis and the y-axis for this parabola. Let me complete it. Okay, first let me draw the x-axis over here. And here we have y-axis. Okay, so let me mark it. This is y, and here we have x. Already we know that a comma 0 and b comma 0 are the two x-intercepts of the given quadratic function. So here a, then we can mark this point as a comma 0. And here let's take b over here. Then it has to be b comma 0. Okay, now I mark the two x-intercepts. Okay, and also when x takes a value between a and b, so let's consider the inequality we have over here. When x takes a value between a and b, so y is what? Positive. So whenever I consider a value of x between a and b, y is positive. Y is positive means the parabola must be above the x-axis, because above the x-axis all the y values here will be positive. So that's true because the parabola opens down. So if I consider any value for x between a and b, so we have the parabola above the x-axis. So on all the points over here, the y coordinate will be positive. So this, the information given in the question is true when I sketch the parabola for this one. Okay, now let's consider, let's consider the point r comma s, because the question says the graph of the given quadratic function contains a point r comma s, and particularly in this r comma s, the value of s is given, that is 10. So we have the point r comma s and the graph of the quadratic function. That means on this parabola, we have the point r comma s. Particularly for this s, we have value that is 10. So then the point r comma s becomes r comma 10. So where will have this point r comma 10? It's above the x-axis or below the x-axis. So here the y coordinate at this point is 10. That is positive. Since the y coordinate is positive, we must have this point r comma 10 above the x-axis, because only above the x-axis the y coordinate will be positive. You can consider this r comma 10 at anywhere on the parabola above the x-axis. For example, if I consider r comma 10 over here, so the y coordinate is 10, and what is the x coordinate? It is r. And it's not like I have to consider the point r comma 10 over here at anywhere on the parabola above the x-axis. For example, if I consider r comma 10 over here, so the y coordinate is 10, what is the x coordinate? Is r. Or if I consider r comma 10 over here, so then I'll have the x coordinate r over here. Okay, if I consider the point r comma 10 on the parabola above the x-axis, so always the x coordinate r lies between the two values a and b. It can be written as a less than r less than b. Okay, now let's consider the three statements over here. The first statement says r has to be less than a. That means the value of r must lie on the left side of a, because only if I consider the value of r on the left side of a over here, then the r value will be less than a, but that's not possible because in our working it's very clear. So the value of r is between a and b. And also let's consider the second statement. It says r has to be greater than b. If the value of r is greater than b, then r must appear to the right side of b at somewhere else over here. So that's also false because it's very clear. Always the r lies between the two exponents of the x-intercepts a and b. So we get the inequality a less than r less than b. We find this inequality in statement 3. So only third statement is correct. So the correct answer choice for this question is option C.